So let us look at one of the problems. I'll explain this problem. So rest of the problems you can go through. So here the problem is three polynomial expressions are given. So these are the three polynomial expressions. So the first column will be representing the coefficient of x2, x1. Second column the coefficients of x2, and third x3, and fourth x4. So what you have to find, this is your A. So Ax equals to B, it is in the form Ax equals to B. So the next find out, the question is, from A to B you reduce it to U to C, and to reach a triangular system, U is in the form of triangular, when you reduce A to U. And find the conditions on B1, B2, B3 so that you have a solution, and describe the column space of A which plane in R cube. Because the column space size of the column, the number of elements in a column is 3, so it is R raised to 3, so that is Rm. Describe the null space of A. To describe a null space of A, Ax equals to 0 you have to solve, and to find out the special solution, I told you the free variables, each one of the free variables has to be unique, and the other free variable is made 0. If you have two free variable, one free variable is made 0 and the other is made 1. So that's how you find out the special solutions. And find a particular solution. So instead of that is Ax equals to B, you have to solve. Then that is solving Ax equals to B means what? You can solve either Ux equals to C or Rx equals to B you can solve. And reduce U to C to R to D. So here you are solving from U to C to R to D. So you can find the special particular solution from Ux equals to C. So coming to the problem, you can see I have just written the coefficients, and this we call it as augmented matrix. First A is written, and then the values of B are written. It can be values. Here they have told you to find out just B1 as kept as it is, B1, B2, B3. So here the row operations are made. So this you can see here these two are made 0. To make it 0 you can apply R2 minus 2 times of R1, and here you can see this is also made 0, so it is 3 here. So we can say 3 minus 3 times of R1, that also becomes 0. If you do then you will be getting it here. So here also you can see a B2 minus 2 times of B1 you have got B3 minus 3 times of B1. Whatever row operations you are applying for the A, the same will be applicable for B also. So that reduces to this value, and so this is still, it is not in a U form. So you have the next, in the second row, the non-zero element is this. Below these elements you have to make 0. So you can see here you have 2, and here you have minus 2. You can just add these row 2 and row 3, so it becomes 0. So you are having 0, when you do that operation you will be getting 0, 0, 0, 0. And if you want a solution, so that is also applicable to this part. So when you are doing this, if you want a solution, so this means what? X equals to 0. So 0 into x, that is 0 into x should be equals to 0. So you get a condition that b3 plus b2 minus 5b1 should be equals to 0 if you want a solution. You cannot have a solution that ux will be equals to some positive or negative values depending on the b3, b2 and 5 times of b1. So it has to be 0 if you want a solution. That is the condition for solvability. So that was your question. One of the question was that what is the condition for solvability? The condition for solvability will be b3 plus b2 minus 5b1 should be equals to 0. That is one of the conditions. So next is was to solve the, this is the condition what I told you. Next is to find out the column space A. So what will be the column space A? Just the columns of A where the piet elements are there. I written just the columns of A, not the columns of U, because column space of A is asked. If a column space of U is asked, you write the columns of U where the piet elements are there. Column space R will be the columns of R where the piet elements are there. The same columns will be the piet in A, U and R, but the column space of A will be the columns of A, and column space of R will be the columns of R. So column space of A is asked, so A is written there. And null space, you have to find the null space, so you have to solve Ax equals to 0. That is, solving Ax equals to 0 means you have to solve Ux equals to 0, or even you can go for Rx equals to 0. So here we have Ux equals to 0 has been solved. This is your U. You can see the first pivot element, one pivot element, and the second pivot element 2. If I solve this equals to 0, you can see 2x3 plus 2x4. We will always start with the equation writing from the last row. So last row is 0x4 equals to 0. So 2x, next row is 2x3 plus 2x4 equals to 0. This will give you x3 equals to minus x4. And the first from the first expression we will be getting x1 plus 2 x2 plus 3x3 plus 5x4 equals to 0. So you can write in terms of x, and we'll be writing always the expressions in terms of the variables. And so we'll have two expressions in terms of x3 and x1. What are the free variables? Free variables are x2 and x4. So which are not the part elements. Other than the part elements are the free variables. So we'll be writing the null solution in terms of free variables. So here you can see the free variables x2. What is the value of x2 in x1? That is minus 2, that has been written. And what is the value of x2 in x2? That will be the variable itself. And what is the value of x2 in x3? X2 is not present, so it is 0. And what is the value of x2 in the free variable x4? X4 is free variable, so it is 0. So next is x4. What is free variable x4? What is the value of x4 in x1? That is minus 2. What is the value of x4 in x2? That is free variable, that will be 0. What is the value of x4 in x3? You can see here it is minus 1. So what is the value of x4 itself in the variable? It is x4 equals to 1. So that will be a null solution. From this, what will be the special solution? Special solution will be when x2 is equals to 0 and x4 equals to 1. And another solution when x4 is equals to 0, what I told you, this is x2 being 0 and x4 being 1 case. And another x4 being 0 and x2 being 1. So you will be getting one special solution this matrix and another special solution this matrix. So that we call it as a special solution from the null space. So next is from you have to solve Ux equals to C, that is for particular solution. So here the values of B has been given. So that, and this is B, and while doing the row operation, when we are reducing A to C, even the B values also changes. So that changes to 0, 6, 0. Just write again the same element in terms of piot variables x3 and the piot variables. You can see in terms of x3, we have the expression in terms of x3 and in terms of x1. Just write the particular solution. How to write the particular solution? You have to substitute the free variables. What are the free variables? x2 and x4. If you substitute them equals to 0, what are the values of x1? It will be minus 9, x3 it will be 3, and that itself will be your particular solution. So you can see minus 9, 0, 3, and 0 are the particular solution. So complete solution will be n plus x2 will be your complete solution. Here you are reducing u to c, uc to rd, that is ux equals to c, and you are reducing to rx equals to d. So that means when you are doing a row operation on u, it reduces to r and c reduces to d. So you can see what is r. R for r, we should have this piot elements should be 1, so it is already 1. So this piot element should be 1, so you can divide it by 2. So it becomes second row, you are dividing it by 2, it becomes 1, 1 and 3. And this element has to be made 0. The elements above and below that should be 0. 3 has to be made 0. So I can do? First row minus 3 times of the second row. It becomes automatically, this becomes 0. So you can have first row R1 minus 3 times of this. So this value doesn't change, only this value changes, and even this value changes. 5 minus 3, that becomes 2, and the same operations are also done here. 3 times of 3, that is 9, 0 minus 9 becomes minus 9. So this is how you are reducing R to C to R.